All right, today's section involves the algebra of functions, which means we're going to be doing things like adding functions together and subtracting functions and multiplying and dividing and determining the domain of each. Just a reminder, in case you forgot, when we talk about domain of a function is all real numbers. Domain of a function, you should be able to do this in your sleep by now, is all real numbers unless, these are the two stipulations that restrict our domain. Unless there is a variable in the denominator, that variable cannot be a value that would make the denominator equal to 0 because you can't divide by 0. Or if there is an even root, like a square root of a fourth root, what's underneath cannot be negative. So you'd have to figure out, well, what values would make it stay positive. So those are our two considerations: a variable in the denominator or an even root. So we're going to start out by just evaluating some functions. I chose some of the ones that were similar to the ones that you have, but not the same ones. So for problem number 1, and this is for problem number 5, you have these two functions. F of x is x squared minus 3, and g of x is 2x plus 1. For number 1, they want me to find f plus g of 5. The easiest way to do that is just to find f of 5 and find g of 5 and add those two together. So f of 5, it means plug in 5 to the f equation. So that'd be 5 squared minus 3. 5 squared is 25. Subtract 3, that's 22. G of 5 would be 2 times 5 plus 1, which is 11. So now all I have to do is add f of 5 and g of 5. 22 plus 11, my answer would be 33. Here's a multiplication one. F times g of 0. The easiest way to do that is just to do f of 0 times g of 0. F of 0 means you plug in 0 to the f of x equation. So that's 0 squared minus 3, which is negative 3, times 2 times 0 plus 1, which is 1. Negative 3 times 1 is negative 3. So f times g of 0 is negative 3. Here's a subtraction one. F minus g of negative 1. I'm going to plug in negative 1 to the f equation. Now be very careful because it's squaring a negative. F of negative 1 would be negative 1 squared, which is 1, minus 3, which is negative 2. And then I'm going to have to subtract the g of negative 1. G of negative 1 is 2 times negative 1 plus 1, which is negative 2 plus 1, which is negative 1. So this is negative 2 minus negative 1. Negative 2 minus negative 1 is negative 1. So my answer is negative 1. F times g of 2. So I'm going to do f of 2. Whoops, I didn't mean to write that high. F of 2 times g of 2. 2. So f of 2 would be 2 squared minus, wow, I'm not doing good on this problem. 2 squared minus 3. I was thinking 4. 2 squared was 4. 2 squared minus 3, which is 1, times g of 2 is 2 times 2 plus 1, which is 5. 1 times 5 is 5. All right, and that's how you do the first ones. I'm going to skip over that next one. This one is where it kind of gets a little bit more difficult. In the rest of the problems that I want you to do tonight, I'd like for you to go through 29, you've got to do a whole lot of stuff for each problem. First thing in part A, you've got to find the domain of f, of g, of f plus g, of f minus g, of f times g, of f times f, and f divided by g, and g divided by f. And then you got to figure out what you would actually get if you were to do all except for the first two. And if I do that, I will run out of room. So let me erase this. So first we're going to talk about domain, and then we're going to come back. Some people ask, can I do it all in one place on my answer? Yes. If you're doing domain and you want to go ahead and talk about what you would get, if that makes more sense to you, to go ahead and do that at the same time, and we may, as we're working through that, do that too. All right, so what's the domain of f? The domain of f, since it's just a linear function, remember we had the rules, if there's no denominator and no even roots, it's all real numbers. The domain of f is all real numbers. You can either write it like that, or you can write it in interval notation, negative infinity to positive infinity. I'm probably going to write the r just because it's hard to write on here. The domain of g. G is also, it's just 4x minus 2. So the domain is, again, all real numbers. For f plus g, if I were to add negative x plus 1 and 4x minus 2, it's still just going to be linear, so it's still going to be all real numbers. If I go ahead and do this, I'll have the answer to part B. So f plus g would be negative x plus 1 plus 4x minus 2, which would be 3x. Negative x plus 4x makes 3x, and plus 1 minus 2 would be minus 1. 3x minus 1 would be my answer to part B, and all real numbers would be my answer to part A for the domain. All right, f minus g. Now the hard thing about that would be the thing that messes people up on the minus part is that you have to remember that it's negative x plus 1 minus 4x minus 2, which means that you have to subtract both things, which makes it minus 4x, and then it makes it plus 2 because it's minus a minus 2. And then when you combine your like terms, you get negative 5x plus 3. So f minus g gives me, for part B, negative 5x plus 3. So the domain is, again, all real numbers. All right, so now I've got to do f times g. So let me erase this, and I'll keep on going. You may need to pause it and make sure you get these examples written down. All right, f times g will be f times g. F times g will be negative x plus 1 times 4x minus 2. My domain, if I multiply this times this, my domain is going to be all real numbers. I'm not going to get a denominator, and I'm not going to get a square root. So my domain is all real numbers. So that's part A, domain. Part B says actually do f times g. So to do f times g, I've got to do FOIL, or the distributive property. Negative x times 4x is negative 4x squared. My outers, negative x times minus 2, would be plus 2x. My inners would be plus 4x, and the last ones would be minus 2. So my answer for f times g is negative 4x squared plus 6x minus 2. All right, then f times f. F times f means I'm just going to do negative x plus 1 times negative x plus 1. So again, the domain is going to be all real numbers, no denominators, no square roots, and now I just need to do FOIL to get my answer for part B. Negative x times negative x is positive x squared. My outers will be minus 1x, my inners will be minus 1x, and my last will be plus 1, which is x squared minus 2x plus 1. So that's what I get for part B, f times f, and this is part A, what's the domain. All right, now I've got the two division ones, which are actually sometimes easier than the multiplication ones, to be honest with you. So division, f divided by g will be negative x plus 1 divided by 4x minus 2. And that's your answer for part B. That's all you can do. Now for part A, when you're doing the domain, you have to look at this bottom. 4x minus 2 cannot equal 0. Cannot equal 0, because then you'd be divided by 0. So if you'll solve that, divide by 4, 2 divided by 4 is 1/2. So x cannot equal 1/2. And you can either write x can't equal 1/2, or I'm going to have a little bit more trouble writing this. You can write from negative infinity to 1/2, and then from 1/2 to infinity. That means x can't be, whoops, sorry, 1/2. I don't know where that screen went. There it is. So either way is fine for the domain. And then finally, the last part of this question, g divided by f, is just 4x minus 2 over negative x plus 1, and that's the answer. And then your domain, so this is part B, and your domain is that the bottom part of the fraction can't be 0. So you solve this. Negative x can't equal negative 1. Divide by negative 1. X can't be 1. So you can either write it like that, x can't be 1, or you can say from negative infinity to 1, and then from 1 to infinity. Hopefully that helps you on those problems, and we'll go over some more examples tomorrow.